Hey everyone, if you want to build out a video agent that can see and hear you, then this video is for you. We're going to be building on top of LiveKit, which is an audio video server, and we're going to be integrating with their video and audio streams to give your AI agent eyes and ears. If you don't know us, I'm Dan McCauley, AI engineer, and this is Dave Odell.
I'm a DevOps engineer.
And we've been working in software for over 20 years. So this is a long video. We're going to jump right into it. Dave's going to give you a demo real quick.
Okay, so this is a AI virtual assistant. You start a session with it, then the AI will join your session, and then you share your screen with it. Then the AI will basically parse your screen and look for errors and help you correct them. So I'm just going to start a session here. At first, the session will just be me, and then the agent will quickly connect. And then I'll share my tab that with the Cloud Dash in. Okay. So the agent's connected, and now I'm going to share the Cloud Dash screen with it. And the cool thing is, I shouldn't even need to discuss what's on the screen. It will automatically parse it. If you look in the logs here, you can see all these lines where it's like capturing frame. So it's basically doing a screen capture of the frame. So I'm just going to be quiet here, and let's see what it does on its own.
I see that the performance metrics widget is showing an error with widget failed to load data and status. Data source timeout. The current refresh rate is set to 1 hour, which is likely causing the issue. To fix this, click the gear icon on the performance metrics widget. Change the refresh rate to 5 minutes or 15 minutes, then click Update Widget. This should resolve the data loading error. Let me know if the widget loads after making this change.
Yep, it's all fixed. Thank you so much. So Dan, I'm going to try and export some data. What I think is going to happen when we use a CSV format, here's a max of 10,000 rows, but the data has 25,000 rows. I think there's going to be an error. What do you think, Dan?
Looks like it.
Yeah, let's try. Let's see. Oh, an error. Hey, we have an error. We're trying to export data. Can you help me resolve this?
You are seeing an export failed, size exceeded error. This happened because you're trying to export 25,000 rows using CSV format, which has a 10,000 row limit. To fix this, switch your export format to XLSX, which supports up to 100,000 rows. Just select the XLSX option under Format and click Generate Export again. This should allow the export to complete successfully.
Okay, so that's great. We just watched the AI agent resolve 2 problems. And one of them we didn't even have to prompt. It just did a screen capture on its own, looked at the knowledge base, come up with a solution, and then prompted me how to fix it. And now the fun part, we're going to show you how we built this.
All right, Dave, that was awesome. Let's dive into the details. So first, I want to go over LiveKit Server. So LiveKit Server is their video platform that's built on top of WebRTC, which is normally a peer-to-peer networking protocol. They've built out a client server to make it more scalable. It's all built in Go and open source. You can either use their platform or host it yourself. Now I want to talk about the AI agent that they built on top of it. So they built an SDK that integrates into the audio and video streams, as well as data streams, so you can see chat messages as well. And it goes through your standard voice agent pipeline. So you go speech to text. They also have a transcript feature, so that's stored. Your front end can hook into the transcript as well as the backend. Then there's the LLM. So you send the text to the LLM. You have the option to integrate tools and RAG. And then the LLM response is again sent to the transcript. And then the text is translated to speech. And you hear that as you did in Dave's demo.
Yeah. Hey, Dan, one thing to point out is that we're not using tools in this case, but we are using knowledge. We have some markdown files.
That's right.
That we're referencing in our demo.
That's right. So we clearly call out where you can hook into it, but we kept it simple because there's so much to go over in this. So let's go ahead and go to the mermaid chart so you can get an idea of what we're doing. So we have 3 different layers here. We have a front end, a backend API, and a LiveKit server. So this is actually the cloud platform, but this you could host yourself. And then we have the agent that we built out. So the front end starts up, you can put your name in, then you have to request a token. On the back end, we're actually creating a new room for every agent, and then we're returning the room as well as the token. So the front end can then connect to the LiveKit server using that token. The LiveKit server will then dispatch an agent into the room, and we'll show you how that happens. And then the agent will send a greeting back to the user. The user then shares its screen. We subscribe to that track. We'll show you how to hook into incoming tracks and subscribe to them and pull video frames off. So LiveKit has full video support. It's only fully integrated with the real-time Google API. In this case, we're manually pulling frames off and we're sending it to LLM. So that way you can integrate with any LLM that's multimodal. So we're capturing frames in the background. The user then speaks to us. Once that speech is translated to text, right here, so speech to text, it comes to the LLM. We will then pull those captured frames, attach it to the LLM call, and then we'll respond. Then it goes text to speech back to the user. So that's what you saw in the demo. That's the high level overview. Now let's go ahead and dive into the code. So here's the code, and we're looking at the front end right now. And so this initial connect is where we actually pull the token from the backend, and we'll walk through that code in a minute. So this pulls the token and the server URL that you need to connect to. So here we have the connect. So when you click the connect button, it calls that connect, and then it will open that LiveKit room with the server URL and the token. And this is all using their React SDK, and you can just throw your video conference component in there. They also have an audio conference component. And if you click into these, you'll actually see a bunch of different components inside of each one of these, so you can get a good idea on how you might want to break it down and create your own custom interface. But we're just using what they have out of the box. All right, let's go ahead and go to the back end. We're using Fast API here. Here's our cores middleware. Obviously, you'd want to fill in the origins and such in production, but this is just a demo environment. All right, first we check to make sure that we have the proper credentials set up. Then we create the room. In this case, we're giving a test room with a random UUID, so we have a unique name for each room. And we have this departure timeout set. So if people are out of the room for more than 60 seconds, LiveKit will actually clean that room up for you. Then we go ahead and generate the token, and we send back the token and the URL. So we create the room so we can pass it in and grant access to the room, so the front end can then subscribe to all the tracks and publish their own tracks. And tracks are video and audio. All right, now let's go over the video agent. Let me zoom down here. So we're going to start by initializing LangFuse. All the traces are recorded, so we know exactly what goes to the LLM. Here we're initializing our knowledge. Let's go to that real quick. We have dashboard, export, and you can see that the knowledge goes over each of the different views, describes the view, and then also walks through common errors and issues. It also provides step-by-step instructions. So this is exactly what the agent was responding with when it was talking to Dave in the demo. In this case, we're just loading all of the knowledge into the systems prompt. So LiveKit calls the systems prompt instructions, but it's the same thing. We have this note here for the LLM not to respond in Markdown. So we're using OpenAI for this demo. OpenAI and most LLMs actually love to respond in Markdown. If you respond in Markdown, then the text to speech will actually say asterisk asterisk or pound pound, whatever. And it's kind of ridiculous. So we have this special note to make sure that it doesn't do that. And then there's some notes about how we want it to look at the screen. And here we're adding the knowledge. All right, let's go into the agent implementation. So we're inheriting from the LiveKit base agent. Then we pass the instructions, the LLM, OpenAI, DeepGram for speech to text, Cartesia for text to speech, and all of these different plugins support more or less all the providers for each one of these layers. So, we could be using, for example, 11 Labs for text to speech if we wanted to. And then here we come down to voice activity detection and turn detection. So you don't actually need to have turn detection to make turn detection work. It will just default to voice activity detection, and then it'll transition to saying that the user is done speaking, and then it will give the chance for the agent to respond. If you use the English model for turn detection, then it will actually determine if you're finished talking instead of just taking a long pause to think. All of these different plugins have a bunch of different parameters. You can see us overriding some of them for Cartesia. The turn detection ones are actually very important to tune. It's a little sensitive by default. And then here's the room that the agent joined. We're going to use this to subscribe to some events. In particular, we want to know when the user or any participant shares its screen. Session ID, so this we're using in LangFuse traces as the session ID. Also, I'd recommend putting it in any of your logs in production so you can map traces and logs back to each other when you're debugging issues. And then here's the current trace. So this is so we can add different spans onto that trace, as we'll see later. Here are all the frames that we've captured. Last frame time. This helps us sample frames. So we're only capturing 1 frame per second because we don't want to bloat memory. And then this is the video stream. So this is a LiveKit concept. We'll go into that when we go over the frame capture. Close is just a helper function that we added here to make sure that we close the video stream, flush any open traces. On enter is a specific method that LiveKit will call when your agent enters a room. And in this case, we want the agent to introduce itself. Maybe you want to just add a note taker or something like that, then it wouldn't need to introduce itself. But in this case, it's a customer support agent, so we want it to introduce itself. Then we hook into a couple of different events. There are a number of events that you can hook into. In this case, we're just hooking in these two. On exit is called when the agent leaves the room. You can generate a reply, and then we're calling our close helper. Okay, get current trace is used to make sure that we always have a LangFuse trace, so it's lazy loading that initial LangFuse trace. On state change was just a debug thing that I was using. I decided to leave it in here because I thought it was interesting. So this will tell you if the user is speaking or listening. And then this one here is the turn detection. So every time the user finishes speaking, we will actually create a new trace and start to record each one of the nodes. Here's the speech to text node. For this one, we are just wrapping it with LangFuse. Then the LLM node is next. We're going to go over this in a little bit. We'll come back up to it because I want to go over the frame capture before we come into here. And then there's the text-to-speech node, which is similarly just wrapping with LangFuse. And whenever we wrap with LangFuse, we want to make sure to have this generic try except clause here, where we tag it as an error level, which is very nice when you're debugging your traces. And we log here. And then we just raise the exception. So we're not swallowing errors, but we do want to make sure that the span has error level set. And then we always want to end the span so we can get proper timing. All right, so on tracks subscribed. You saw this in the constructor. So when any participant actually shares their screen or unmutes themselves or starts turning on their video, you're going to get this on track subscribed event. In this case, we only care about when they're sharing their screen. So you can actually see if it's a microphone or a screen share or a camera. On the track, there's also a property that says whether or not it's video or audio. In this case, screen share is always video. I don't have that extra check here. So if it's anything other than screen share, we ignore it. Otherwise, we start to stream the video. So here's a little cleanup. We make sure that we close any video streams that were already open. Then we assign the new video stream and we start streaming from it. So we get a bunch of different events. Each event is a video frame in this case. And here's our sampling. Very simple. It's just if it's been more than a second since we captured the last frame, then we're going to pull the frame and add it to our list of frames. And we capture the last frame time. And a little bit of logging here for debugging purposes. And then in what we do here is, depending on the number of frames, we determine which frame we want to send to the LLM. So we always send the most recent frame. If there's more than 3 frames, we send the first frame and the most recent frame, and then if there's more than 5 frames, we send the middle frame as well. This is kind of arbitrary. I just did it because I didn't want to send a ton to the LLM, but I also thought it would be useful to send maybe some frames in the middle as well. But I imagine if you're actually building this in production, you want to have a little bit more control and maybe be a little bit smarter about which frames you send to the LLM. I was actually originally only sending frames when the user was speaking, but I found that wasn't not enough frames, because what would happen is when the agent was speaking, we'd be following the instructions, and then we'd fix the issue, and we'd be like, all right, what do you see? And it wasn't enough time to capture a frame sometimes, but if it's on all the time, then you're pretty much guaranteed to send a frame to the agent that sends the relevant content. All right, so here we pull the current frames, so that's what we just went over. Then we add the frames to the chat context. So let's actually go over the parameters here. This is the most crucial point when you're making an AI application. You really want to hook into the LLM node and have full control over what happens. So this is where you could actually manually introduce RAG. So if you already have a RAG system that you're building for regular chat and you want to reuse the same system for voice, then maybe you don't want to hook in and use all of the decorators that LiveKit provides, but they do provide decorators for tools and RAG and things like that. In my case, I often do it all manually here because this is the part that we're comfortable with as AI engineers. But you get your chat context, you get your tools, when you get your model settings. Model settings, it's a pretty simple struct. I think it has one parameter that didn't seem very useful. So in this case, I am actually copying the chat context because we didn't want to mutate the underlying chat that LiveKit is storing. But you could potentially attach all these image frames and then it would be around for the next LLM call. But we're actually just attaching the most recent images instead of keeping images in the past. So that's why we're copying here. And then we're adding the image messages to the chat. So here we're adding a note plus the image content here. So you can see content is a list. So there's a text portion of it and an image portion of it.
Yeah, you'll see all that in LangFuse, which is pretty amazing.
Yeah, for sure. And then if there are no frames, then we send a note and say the user's not sharing their screen. So the agent will actually ask the user to share their screen so they have a little bit more context. And then we're using this OpenAI utility method that LiveKit provides because LangFuse supports OpenAI message format. So it's a very nice utility to just transform from the LiveKit format to the OpenAI format. And you can specify whichever model you use. Just because you're using the OpenAI format doesn't mean that LangFuse will assume OpenAI. You could put Anthropic here and it will interpret it appropriately and do the right token and cost calculations. All right, and then we're just calling the underlying LLM node. So this is forwarding that new copied context to the OpenAI LLM. We're adding a set completion start time. So when you're streaming, LangFuse has a property for completion start time. This lets us know how long it took for that first token on the response. And then we're forwarding everything back up to LiveKit here when we yield the chunk. So it's a little wrapper around what they do, but you see how much control we actually have. We could have created a new chat context from scratch. We could have used whatever we want. We have full control over what we send to the LLM. Then we have the little error wrapping here, and we close out the generation. All right, so that's the LLM integration, and that's the most important part. So when you're creating your own agent, this is where most of your code is going to live. Let's go ahead and scroll down. I want to go over one last piece here, which I think is pretty cool. So LiveKit agents actually scale horizontally. You can start up as many instances of this process, and LiveKit will distribute the load across your worker instances. And so every time a agent is dispatched or a room is created, your worker will be called. There's a few different parameters here. We're just using the entry point one. So our entry point gets called. We connect to the room. We check to see if there's any participants. If there's no participants, we just exit out. Otherwise, we create an agent session. We create our video agent. Then there's room input and output. So video and audio are enabled. Transcriptions are enabled. We want access to all the video and audio and transcriptions. And then you start the session. So relatively straightforward. I think the cool part here, though, is that LiveKit will scale with the number of workers you create. So you really get to take advantage of their platform that they built. All right. Now I want to walk you through some LangFuse traces. You can see our video agent trace name that we added, and then we have the different nodes in the trace. And then you can scroll down here. You can see it starts with our instructions and then all the knowledge that we added. And then finally, you can see the images that we're sending to the LLM as well. So this is after Dave fixed the issue, and you can see that it's no longer read anymore. And there's actually one thing that I discovered when I put these spans in. You can see that we actually only have the LLM generation and the text-to-speech node in here. There's no speech-to-text. And that's actually because the speech-to-text doesn't end right away. You're continuously streaming to that speech-to-text node, and it doesn't get called on every turn. Normally, I would have probably just ripped out the span because it's not actually serving the purpose that I thought it would serve, but I left it in here because I thought it was an interesting thing to call out, where it makes a lot of sense when you think about it. You're streaming all of the audio to the speech-to-text, and then it identifies voice activity and it uses the English turn detection to finally determine when the user has stopped speaking. And if you were to try to cut it off after each one of those transitions, it probably wouldn't work as well. So it was just a cool thing that I noticed, even though when we first looked at this, it looks very much like speech to text. That's just one span here. This is actually just a continuous node that just stays open the entire time that you're streaming. So that's it for LangFuse. That's it for the code walkthrough. So now you're equipped to go off and build your own video agents. What do you think, Dave? I mean, this is pretty awesome, right?
Well, it's totally awesome. And let's just go over things. It's text to speech and speech to text. It's also image to text. It's probably a couple other things in there as well. It's also set up so that if for some reason a actual human, a customer service agent, wants to enter that room, they could. So you'd be yourself, and then an LM agent, and then a actual human.
Exactly.
So it's really powerful. Also, like shooting these videos, we use this particular piece of software, and every time that we go to shoot a video, there's some type of issue that if that software had an LLM agent that we can say like, share my screen, what is going on with this? We experienced this in real life. And so I feel like that company should hire us to create an agent to help as a customer service agent. But
no, seriously, I can't even imagine how nice it would be. Like I am going to like GPT or Claude or something and typing things in, and it's searching the web for me. But just imagine if they had their knowledge base set up. I could just share my screen, show the exact issue, and they're like, boom, done. I could have just used the video agent.
We're dealing with customers, right? Privacy is a big issue, and everything that Dan showed today is all open source mostly. And so, like, host as much of this stuff internally as possible to not have to deal with privacy issues, because that's always a big deal. So keep
Yeah,
that.
all the content will be streaming through LiveKit. If you use their cloud platform, they don't actually store anything. They track all the metrics of, how much data was going through the cloud, and then they
Yep.
give you an option to store it to your S3 bucket or Google Cloud storage. But yeah, if you host it yourself, then you have complete control, right? And that's one of the very powerful things
Yep.
about these open source projects.
Yep.
All right, well, that's it for today. Thanks for your time. If you enjoyed the video, leave us a like, subscribe, comment if you have any questions. And if you want to work with us, there's a link in the video to schedule some time to talk to us about your projects. All right,
And
thanks
as
everyone.
always, on our GitHub page, this demo is ready for you. You'll have to create a few accounts and get some API keys, but this thing's ready to go. So have fun with it. Let us know how you use it.
Awesome. All right, thanks everyone. See you next time.
Bye.